Hey guys, in this video, we're going to be doing lesson 5.6, which is solving quadratics by square roots. And I'm doing this one a little different because I don't have access to my iPad today. So hopefully you don't mind the change. So a radical is any expression with a square root, cube root, any kind of root. And that symbol, you're used to it, looks like that. And so I want you to go through, or we're going to list out the first 12 perfect squares. So perfect square is like 1 times 1 is 1. 2 times 2, 4. 3 times 3, 9. And if we keep going all the way up, we get 16, 25, 36, 49, 64, 81, 100, 121, 144. Actually, let's go up to 15. 13 would be 13 times 13, 169. 14 times 14 is 196. And then we have 225. So that's up to 15. Before we get started actually looking at quadratics and looking for x-intercepts, we're going to learn to actually simplify the radicals. Let me adjust this a little bit to make it a little closer. All right, so square root of 49. When it's a perfect square, you just get an answer. And that answer is 7. Hopefully you knew that. 225. Square root of 225 is 15. Now, number 3 is 2 square root of 144. So that's really 2 times the square root of 144. And we know that the square root of 144 is 12. So 2 times 12 is 24. You can also take the square root when you have fractions. So the square root of 4/9 is really the square root of 4 over the square root of 9. You just take the square root of the top and the square root of the bottom, which would be 2/3. Square root of 2, or square root of 4 is 2, and the square root of 9 is 3. Number 5, we can do the square root of 1 over the square root of 81, which is 1/9. But then we get to number 6, and this one is not a perfect square. So we aren't just going to get a whole number, and we don't type it in the calculator just to get a decimal. What we do is we look for the largest perfect square that goes into 112. So we use our calculator, we divide 112 by the perfect squares to find one that goes in evenly. So you might want to have your list handy and your calculator. All right, so 112. Now, because I'm looking for the largest, and that's important, it needs to be the largest. Let's start with bigger numbers and work our way back. It doesn't make sense to divide by something bigger than 112. So starting with 100, but you should know that 100 isn't going to go evenly. So let's start with 81. Oops, I already typed that. Divided by 81, not a whole number. So let's work our way back. 64, nope. not 49, not 36, not 25, and 16 it is. So see how 16 went evenly into 112. So what we do is we're going to break 112 down into square root of 16 and the square root of 7. It's important that you keep putting these square root symbols because the square root of 112 breaks into square root of 16 times square root of 7. And we know that the square root of 16 is 4. And then the square root of 7 doesn't break down. So we just write our answer as 4 radical 7. Number 7, let's follow the same steps. Let's look for the largest perfect square that goes into 245. So if we start with 121, it's not that. 100 doesn't for sure. 81, nope. 64, nope. 49, yes. So we can break this down into the square root of 49 and the square root of 5. Because 49 times 5 is 245. And the square root of 49 is 7. Then we have the square root of 5. So my answer is 7 radical 5. Number 8 has a 5 out front. So after I break down the 72, I'm going to multiply that by 5. All right, so 72, if you take 72, just like we were doing with the calculator, and divide it by your perfect squares, the biggest one that goes into 72 is 36. So the square root of 36 times the square root of 2, because 36 times 2 is 72. And we know the square root of 36 is 6. We just leave square root of 2. But we have this 5. So you can multiply numbers that are outside of the radical. So 5 times 6 is 30. And then radical 2. You only multiply numbers that are outside of the radical or numbers that are inside of the radical. Number 9, we have a 3 that we have to bring down at the end. So 45, take your calculator, 45 divided by those perfect squares. And the biggest one that goes into 45 is 9. 9 times 5 is 45. And the square root of 9 is 3. So we have 3 radical 5. But we have to multiply by 3. So my answer is 9 radical 5. All right, so let's turn our page over. And now we're going to actually get into some quadratics. And so when we have a quadratic in this form, ax squared plus c, we're missing the bx. Then we can do by the square root property. And so what we do is we solve for x. So just like a two-step equation, you just solve, but at the end you're going to have an x squared equals some number. Instead of just like x equals 2, it might say x squared equals 2. We still have to get rid of the squared by taking the square root. So x is the square root of n. Now, something that's new is that whenever you have the full quadratic, it doesn't just say the square root of 10. You have like a full equation here. Then you have to have the positive and the negative of whatever your answer is. You have to have a plus or minus. And I'll show you that with our first example. So number 1, to solve this equation, we would first add 64 to both sides. Those cancel, giving us x squared equals 64. And then we take the square root. And so generally you would write x equals 8 because the square root of 64 is 8. But we need to have positive 8 and negative 8. Now you can write it with the plus or minus, or you could write 8, comma, negative 8. So let me show you why we have to do that. It's because when we're actually talking about a parabola, that parabola crosses at negative 8 and positive 8. So that's why we have to include both. And I'm going to, just to help you out a little bit, I'm going to write that list of those perfect squares. That'll help you out. All right, so number 2, if this was just a regular equation, we would subtract 8 from both sides. Those cancel. 7x squared equals 7. And then we divide by 7. So x squared equals 1. And then we take the square root. So x equals, the square root of 1 is 1. But we have to include plus or minus 1. Number 3, we subtract 5. Those cancel. 81x squared equals 16. Then we divide by 81. And you're going to be tempted to just type 16 divided by 81 in your calculator and get a decimal. But remember, on the front side of the page, we worked with square roots of fractions. So let's just leave it as a fraction. And then I take the square root. So x equals plus or minus, the square root of 16 is 4. Square root of 81 is 9. Number 4, we subtract 1. That leaves us with 8x squared equals 16. And then we divide by 8. So x squared equals 2. And then we take the square root. Now 2 is not a perfect square, but there's no perfect squares that go evenly into it. So when I write my answer, I just write plus or minus the square root of 2. Number 5, add 9 to both sides. 2x squared equals 64. And then we divide both sides by 2. x squared equals 32. Take the square root. Now 32 is not a perfect square, so we have to break it up. Remember, you want the largest, not just any, it has to be the largest perfect square that goes into 32. And that is 16. 16 and 2. So x equals plus or minus, the square root of 16 is 4, and then we just bring down the radical 2. Last one, subtract 10 from both sides. And we get 5x squared equals 300. And then we divide by 5. To get x squared equals 60. And then we take the square root. 60 is not a perfect square, so we have to split it up. We want the largest perfect square that goes into 60. And this one is actually 4. 4 times 15 is 60. So x equals plus or minus, square root of 4 is 2 radical 15. If you have any questions, don't hesitate to reach out and ask. Have a great day.